Hello. This video is for the Algebra 1 textbook. It is Chapter 4, Lesson 2. This lesson is titled Relations and Functions. And the objectives for this lesson are to identify functions, find the domain and range of relations and functions. The vocabulary is relation, domain, range, and function. So why should you learn this? Well, you can use a relation to show finishing positions and scores in a track meet. In lesson 4.1, you saw relationships represented by graphs. Relationships can also be represented by a set of ordered pairs called a relation. So we've talked about ordered pairs in other lessons before, and so we're going to revisit it here in this lesson as well. In the scoring system of some track meets, first place is worth 5 points, second place is worth 3 points, third place is worth 2 points, and fourth place is worth 1 point. This scoring system is a relation, so it can be shown as ordered pairs. An ordered pair, in the past I've talked about that, it is an x value and a y value separated by a comma contained inside of parentheses. We'll get to the whole x and y thing later on. So the braces that we have here at each end, this represents that it is a set. So we have 1, 2, 3, 4 elements of the set. Each of those are an ordered pair. First number is the x value. Second number is the y value. They have a comma in between them, and they are contained inside of parentheses. So they are indeed ordered pairs. Our ordered pairs are 1, 5, 2, 3, 3, 2, and 4, 1. You can also show relations in other ways, such as tables, graphs, or mapping diagrams. So we're going to take a look at some tables, graphs, and mapping diagram. Here on our next slide, this is a table down here. This is a graph here, and this is a mapping diagram. So the domain of a relation is the set of the first coordinates, also known as the x values, of the ordered pairs. The range of a relation is the set of second coordinates, or the y values, of the ordered pairs. The domain of the track meet scoring system is 1, 2, 3, 4. We can see that over here. I brought the paragraph from the previous slide over to this one here, so we can see that 1, 2, 3, and 4 are all of the x values in each of the ordered pairs, so they are the domain. The range is all of the y values, and that set is 5, 3, 2, and 1. And likewise, over here in the set of the scoring system, we see that the second values are 5, 3, 2, and 1. Those are all that is known as the range, the y values. So finding the domain and range of a relation. Give the domain and range of the relation. Well, we see here in green that the domain is all the x values from 1 through 3, with 1 and 3 being included. That's what inclusive means. So the domain, and I like to teach domain, it is the x values. So it is this horizontal axis. Horizontal, like the horizon or like the land. If typically we might have flat land. I know some people might live where there's mountains. But the land pretty much is flat. It's where you live. It is your domain. So that's how I remember my x values of the domain, because the x-axis is horizontal, flat like the land, and the land's where we live, and where we live, well, that's our domain. And then on the blue text here, the range is all the y values, 2 through 4, and 2 and 4 are also included. We know it's included because it's got the solid dot on the end, so we know that those values are included. We learned that whenever we were doing compound inequalities and graphing those. So how do I remember range? Well, obviously, if I have a memory device for the domain, then I probably have a memory device for the range as well. And that memory device is, well, first of all, I know that the vertical axis here that I've just put in, highlight that there, kind of put it in blue. Maybe I should have done it with, maybe let's try green. We'll try a green line instead. And we'll put that in there. Maybe it won't blend in so much with the blue lines there. But nonetheless, it is the vertical axis here. And I know that whenever I go to the firing range, there's the word range, and I aim my weapon downrange, and I need to adjust my aim by either lowering or raising my sights to match up with the target. So as I aim down range, I lower and raise my sights to get the target lined up. So horizontal, x-axis, the land I live on, domain, all the x values are the domain. Aiming down range, the up and down, all the y-axis, well, that's indeed our range. So in this case, on the graph up here, we know that our domain is all the values between 1 and 3, 1 and 3 being included. Note the half and equal sign there with those inequality symbols. And our range is anything from 2 to 4. That is for the y values, right? And 2 and 4 both included because, again, we have the half and equal sign there showing that 2 and 4 are part of the range. So let's give the domain and range of each relation. Well, first on the mapping diagram here, let's go ahead and list our domain. So our domain is all of the x values. So we'll go D, semicolon. We're going to draw a brace there to show the set. And we have 6, 5, 2, and 1. So let's list those. 6, 5, 2, and 1. We want to separate each element of the set with a comma. So it has 4 elements in that set. And then for the range, well, that's all of our y values over here, right? These are the x values. These are the y values. The x values are being mapped with arrows to the y values. So our y values, let's go ahead and put a bracket in there. We have -4, -1, and 0. That is the domain. And another thing I want to point out about this particular map diagram is that notice we're mapping with arrows, and this is a relation because everything in the domain is being mapped to something in the range. So we know it is a relationship. Now over here on 2b, let's see if we can look at this table here. We know that our domain is all of our x values. So 1, 4, and 8. 1, 4, and 8 are the elements of our domain. And then our range. And you'll notice something about this. We have 2 1s there. One, if, the value of x, whenever x is 1, y is 1. We also see that whenever x is 8, that's also 1. So the idea is that we only have to list each value that shows up one time. So we have once showing up twice, but we only need to list it once. So we'll list 1 and 4, and that is indeed our range. So let's go ahead and look at our next slide. And now we're going to talk about identifying functions. And the idea of functions is a little bit different than relationships. You see, not all relationships are functions, but all functions are relationships. And the thing about a function is, and we have the definition of a function here, is that a function is a special type of relation. So we see that functions are indeed relations, but not all relations are functions. So a function is a special type of relation that pairs each domain value, each value of x, with exactly one range value. That would be all of our y values. Now, the thing about words like domain and x value, well, another word that ties in with the word domain and the x values is input. So I'm going to go ahead and put input here. When we talk about functions, we talk about the input. We're talking about the x value. We're talking about domain. And with range, well, you might be guessing if one's input, then the other one must indeed be output. So whenever we're talking about the range or the y values, we're talking about the input. So we could reread this definition as a function is a special type of relationship that pairs each input with exactly one output. Like my professor says, a little bit different, good old Dr. Ewing, he says that a function is a special relationship in which every input has one and only one output. That is to say that every x value has one and only one y value that it's paired up with. So with that in mind, let's go ahead and give the domain and range of each relation and tell whether the relation is a function and that we should explain. So our domain here, I'm not going to write them out, but our domain is the x values, 75, 68, 125. As a matter of fact, the textbook's already done that for us, right? So even though 2 appears twice in the table, it's written only once when writing it in the range. So here we do see that the range or the y values are the outputs. Either way, all 3 words, same thing. Range, y values, output. We have 2 listed twice, so we only list it once. And then we also have a 3. So we have the domain and we have the range. Well, this relation is a function. Each domain value is paired with exactly one range value. So 75 is to 2, 68 is to 2, and 125 is to 3. So it is possible for 2 separate x values, 2 different elements of the domain, to be paired up with the same element in the range. That is to say that 2 different x's can be mapped to or paired up with the same y value. Let's look at the writing math. When there is a finite number of values in the domain, a range lists the values inside of braces. Again, the braces here show that it is indeed a set. Finite means a limited number of. If we had an infinite number of, we would have to use what's known as set builder notation. So here we have a mapping diagram here, and I really like mapping diagrams whenever it comes to functions. And here's why. It's easier to see what's paired to what. Now, the analogy I like to use with this is that if these are people shooting at targets, right? So these are the shooters here, and that is your X values, also known as your inputs, which is also known as your D for domain. And these are all of the targets, Targets, also known as the Y values, and also known as the outputs, PUT, and also known as the what? The range, right? So all 3 of those words synonymous with one another. Now the thing about a function is 2 people or 1 person cannot shoot at 2 targets at the same time. People make arguments, well, you could shoot one and then the other real quick. No, it's like simultaneously shooting. You can't shoot 2 targets at once. Now 2 separate people could shoot the same target. For instance, up here in this first one, up top, here 75 is shooting at target 2 and 68 is shooting at target 2. And yes, that was my cell phone you heard. So I'm coming out of a pause to finish this. But like I was saying, 2 people, 2 shooters, like shooter 75, shooter 68, can shoot at the same target. But like here where we have number 7, shooter 7 is trying to shoot at -1 and 0 at the same time. This means that it's not a special relationship in which every x, and I mean every x, and 7's one of those x's, is paired with one and only one y value, or input is paired to one and only one output. Here, 7 has 2 separate outputs, -1 and 0. So this is not a function. So in a mapping diagram, how do we determine is it a function? We go ahead and look, is one of the shooters shooting at 2 separate targets at the same time? If that's the case, not a function. 2 people can be shooting at the same target. For instance, 12 and 7. If we remove this one arrow from 7 to 0, if we remove that, we'd be good to go because 12 and 7 are both, it's okay for them to shoot at the same target. That is possible. So our domain, 7, 9, 12, 15, we see that here. And our range, -7, -1, and 0. All those numbers right there, that is indeed our range. So as we see down here, this relation is not a function. Each domain value does not have exactly one range value. The domain value of 7, it's paired with the range values of -1 and 0. That is to say, this particular input, 7, has more than one output, -1 and 0, so it is not a function. All right, so let's go ahead and look at the next page here. Give the domain and range of each relation, tell whether the relation is a function, and explain. And helpful hint, to find the domain and range of a graph, it may help to draw lines to see the x and y values. So we see that over on the right. We have blue lines going horizontally to show us the range from this value of 0 here up to that value, or this value of y here, up to this value of y. That shows us the range, the y values. And the domain are the green vertical arrows here. which is showing us our domain, all of our x values across here. So we have x values from, what is that? That's 0, -1, -2, -3. So we must have -4 over here and +4 over there. So all the values of x across here are from -4 to +4. And then all of the y values, likewise, 1, 2, 3, up to +4, and then down to -4. So the range is all values -4 to +4. So if we go ahead and list this as a table, match some of those up, if we plug in a 4, we get 0. So where x is 4, y is 0. Indeed, x is 4 here. And we see that the value of y is 0. So 4 would match up to 0. Where x is 0, we see that we have a positive value of 4. But also where x is 0, we have a negative value of 4. So we know that this is not a function because here's 0 with an output of 4 and 0 with an output of -4. Two separate outputs, therefore it's not a function. We'll talk about the vertical line test in just a moment. So this relation is not a function because there are several domain values that have more than one range value. For example, the domain value of 0, we see here and here, is paired with both 4 and -4. Now, vertical line test. The thing about functions are, and if you're ever asked, and that's not what I wanted to do, I want a line, so let's grab a line. If you're ever asked, what's the definition of a function? Because they do ask this question in college. Do not quickly think, hey, I know the right answer. I'm going to raise my hand, give it the answer, and shout out, it's a function if it passes a vertical line test. Well, while that is true, that is not the definition of a function. Definition of a function is a special relationship in which every input has one and only one output. Yep, somebody did that in Dr. Ewing's class and real quick got shot down real quick like, well, that's true, but it's not the definition. So still remember that story to this day. So if you take a vertical line and drag it across to any function, if you can get it to cross the line in two separate places anywhere, then it is not a function. So let me explain that. So as I'm dragging across here, at this point, you might have just hit in one spot. But the minute we cross over into this circle, look at all the places that it's hitting more than once. I'm going to go ahead and use a green dot here. So right there it's hitting, right here it's hitting. So that would be a violation. And technically anywhere else across here would also be a violation as we drag that along here. Look, we got this spot here. We can show two places where it's crossing the vertical line is crossing the relationship, the graph, in more than one place. If you can get that vertical line to cross more than one spot anywhere on the graph, then it is indeed not a function. It's a relationship, but it's not a function. So let's go ahead and give the domain and range of each relation, tell whether the relation's a function. So I like doing maps on this one here. Let's make a map out of this one here. That way we could tell. And let's get a box here, and let's go back to red. Let's get a box here. We're going to go ahead and create our x value box, or that is to say our range, also known as input. And this will have, for all of our outputs, we'll list them in there and map them out and see what we got. So all the x values, range, right? So 8, -4, looks like -6, and +1. And this is our domain, also known as our x values and also our inputs. And then let's go ahead and list our range here. We have 2, 1, 2, and 9. 2, 1, 2, and 9. Now we see 2 showing up twice in the domain or in the range, correct, for our y values, but we don't know yet. Let's go ahead and map it. I'll go ahead and change to a different color here. So 8 is mapped to 2, and -4 is mapped to 1, and -6 is mapped to 2, and 1 is mapped to 9. So looks like we don't have any shooters trying to shoot at the same target at the same time. So this is our domain. We see here, we've listed the domain, and here's the range. We could put it into with brackets, right, and so forth, but not going to do that. And indeed, it is a function. Now let's look at the map diagram they've already created for us here. 4, 3, and 2, that is what? Our domain, right? And our range is all the outputs, also known as the y values. But is it a function? Well, 4 is mapped to -3. Yeah, that's good. 3 is mapped to -5. Okay. But 2 is trying to shoot the shooter here. Shooter 2 is shooting targets -5 and -4. So therefore, this example over here on the right, 3b, this is not a function. All right, guided practice. Let's look and see what we got here. Vocabulary. Apply the vocabulary from this lesson to answer each question. Using a mapping diagram to show a relationship that, use a mapping diagram to show a relationship that is not a function. Well, let's go ahead and create a map diagram real quick. And I want to work with white because I want to be on the black background. So let's create one there. Let's get a box for our range, also known as the x values, also known as the inputs. And then let's have another one here. And actually, I think I got a smarter idea than that. Let's go ahead. Oh, that's not what I want to do. Come on, Mr. T. Yeah, select. I want to go ahead and grab that. I want to group it. I want to duplicate it. And look at that. So much quicker, right? Let's come up with some numbers. Just keep it simple. 1, 2, 3, and we'll do 4. And let's do 3, 2, 1, 5, right? And I want to double map it. I want to make it to where it's not a function. So let's get rid of one of those numbers. And then let's do some mapping. Let's say that 1 goes to 3, and 2 goes to 5, and 3 goes to 2, and 3 also goes to 5, and 4 goes to 2. Well, this would not be a function. Now, we're okay with 3 and 4 both shooting at target 2. However, target 3 cannot be shooting both at 2 and 5. So this would be an example of a mapping diagram that is not a function. Number 2 says the set of all x values for a relation is also called the blank. So the x values, is that the domain or is it the range? I'll take just a moment, give it some thought. Well, the x values are on that horizontal axis. Whenever we graph it, am I still in white? I think so. We have a y value. We have an x value. Well, the x values, right? It's the horizontal one. This is like the flat land. Like this is where we live. This is our domain. Had to cheat and look up to see how to spell domain. So it is the x values that are the domain. So our correct answer in this case would be domain for this one. On the step example, see example 1, questions 3 through 6. Express each relation as a table, as a graph, and as a mapping diagram. I think I'm going to go ahead and skip that one. Okay, we've done some mapping diagrams, and I'm not really going to take the time to do a table. So let's go ahead and look at the next slide. Anything I want to do on this one? Give the domain and range of each relation. So let's go ahead and do, that's not what I wanted to do. Let's go back to that. And let's do number 7. And can we see it up there on the thing? Yep. Let's move down here a little bit. Let's do question number 7. So for our domain, semicolon, braces to show a set. Let's list the elements. -5, 0, 2, and 5. And if you're like, where are you getting those numbers from, Mr. T? Remember, up here, the x values come first. X is our domain. So all of the first numbers here. And then also, let's go ahead and list our range. R semicolon, or is that a colon? I always get those mixed up. And then the y values is 7, 0, 7, 0, -8, and -20. All the y values there. And then also number 10. Let's go ahead and do that as, let's list number 10. And let's do that using compound inequality statements. We'll do and statements. So in this case, we know that our domain, the domain is all the x values, so we'll throw x in the middle. We know the arrows point left. The lower value goes on the left. Well, the lowest value of x is 0. Greatest value of x is 3. And they're in 0 and 3 are included, so we want to give it that half an equal sign. And then for the range, put the y value in the middle. Both the arrows point to the left. The lowest value of y is 0. And the greatest value of y is 3. So both of these are 0s and 3s. That's the domain and the range using compound inequality statements here. And then finally, let's pick something from example 3. Give the domain and range of each relation. Tell whether the relation is a function and explain. Well, let's look at 13. Well, the domain's all the x values. -2, -1, 0, 1, and 2. And the range is all the y values, 1, 1, 1, 1, 1. That's interesting. I think they're trying to get you to say that this is not a function because you see all these 1s here. But in this case, -2 only goes to 1. So basically, the x value is like your shooters, right? The y values are like the targets. Just so happens to be you got 5 shooters all shooting at just one target. Hey, that's still a function. And then finally, let's use that vertical line test. This is kind of like the other problem that we had earlier. We're going to take this line here. That's not the line. I want to grab the line. There we go. Got a hold of the line. So I'm going to take this line. I'm going to drag it across this graph. If I can get it to touch any place, 2 places, if I can get the graph to be touching the line in 2 separate places on the line at the same time, not a function, right? So start dragging across, and sure enough, I start finding places right along there. Let's just pick one. We'll pick this spot right here and right here. So whatever this value is, looks like about 1.5. It has 2 separate outputs, which looks like about 1.75 and -1.75. Pretty close, just an estimate. Well, in this case, not a function because we have an input, whatever the value x is right here. Let me mark that a little better. Whatever the value of x, let's see, what do I have? We'll go with that. Yeah, but whatever the value x is right here, it has 2 outputs. It's matched up with this one here. It's matched up with that one there. So that x value, one person shooting at 2 separate targets, can't do it. It is indeed not a function. So that is it for all of Algebra 1 textbook, Chapter 4, lesson number 2, titled Relations and Functions. Now, go level up your learning.